Alright, and we're live here. We're looking at the part 2 of the Newton's Laws of Motion test. If you're looking for the stats, or the part 1 that's in the other video, that should be on my page there. So here is the part 2. Now, there were 3 different versions, so this doc just has all 4 questions, all 4 possible questions with all possible parts. So we'll just go through them all one by one. I mean, it may not be your number 1 or your number 2 question or whatever, but I'll cover all of them here. Hopefully, let's see. So long as, oh, perfect. Perfect. So I'll flip this and look down here at my whiteboard to see the work. We'll go over the question, then I'll show you how to do it. What do I need to? I need to flip this. I think that makes it look right. All right, so let's see. All right, I think this is facing the right direction now. So the first one, you have a 64-kilogram teenager that's standing in an elevator and they decide to weigh themselves. So let's get our markers here and let's start this one. So we've got an elevator. You draw that. What else? We have a 61 kilograms. So they have a mass of 61 kilograms. So of course you have Fg pulling them down. Likewise, you have the force of the scale pushing them up. So the first part says calculate their weight in newtons. All right. So to do this, we need to get their force of gravity because that's what your weight is. So here's your equation. Oops, I'm a little off the screen. There's your equation. Now you got to substitute with units. So Fg equals 61 kilograms times negative 9.81 meters per second squared. Multiply those. 61 times negative 9.81 and get your answer. Fg equals negative 598 newtons. So that's part 1. Part 2, after the door closes, it begins to accelerate at 2.5 meters per second squared. What does the scale read? So they want to know what's the scale read. So we know that F net equals ma, but we also know that F net here is this and this. So you have the force of the scale plus the force of gravity because you have 2 forces acting equals ma. So force of the scale plus negative 598 newtons because we found that equals your mass, which is 61 kilograms multiplied by the acceleration, which they said is 2.5 meters per second squared. Well, let me zoom in here so you can actually see it. There you go. Blink. Then you do your math. So you do 61 times 2.5. You get 152.5 plus 598. So you get Fs equals 750.5 newtons. Some students messed up here. They didn't have a negative sign, so you subtracted it. You didn't add it when you brought it to the other side. So there's part 2. And some exams only had that. And the last one is calculate what the scale reads when you have a constant velocity. Love this part. So what will it read when you have a constant velocity? So you're going back to this step because all you're changing here is you're saying, oh, we don't have 2.5 meters per second squared. Constant velocity means I have 0 acceleration. So the force of the scale is going to be positive 598 newtons because 0 times 61 gives you 0. You add that to the other side. There you go. Again, calculate, so you had to show your work. Question 2. The block question here. So which vector should be decomposed? Hopefully you said vector 2. And that's because vector 2 has a vertical and a horizontal component. Vector 1, or F1, only has a horizontal. So we don't need to decompose it. It's already in the X or Y. So we need to split F2 up into a vertical and a horizontal. So it's only an X and Y. So to do the next part, you don't need to show your work. What's the vertical component of the vector you chose? So I chose vector 2, which is 80 degrees. So I go to my calculator. I make sure I'm in degree mode. Here we go. Degree mode. Nailed it. And I do 80. Vertical is sine Sorry, the glare's killer. Oh, wrong one. Oh, jeez, I'm all over the place. Sine of, what's the angle? 50 in this question. So I just do 80 sine of 50. I get 61.3. And then if I want the horizontal, I just switch it to cosine, and I get 51.4. So there you go. Oh, I want to go right here. So now for the next part, they say what's the resultant of the two forces? So the two forces are F1 and F2. So to get the horizontal component, we first have this vector, which is F1, and F1 equals 60 newtons. Then I found this vector, and this is called, this is AX, and we just split up F2, and that's what was 80 cosine, that was 51.4 newtons. And then we had this one here, which is AY, and that was equal to 80 sine of 50 degrees, which is 61.3 newtons. So then to find our resultant, we just draw it in because we've already lined it up tip to tail. So this is R, and we need to solve that. And to do this, we do A squared plus B squared equals C squared. So A is 60 plus 51.4. So A is 111.4 newtons squared plus B, which is 61.3 newtons squared. That equals C squared. So let's see, we'll do this. Plus 61.3 squared. Square root of the answer. Good. So C is equal to 127 newtons. That's what your resultant is equal to. And then the last question was, well, find theta, find the angle. So pause if you need to see this. I'm going to wipe it out. So to do this, we do SOHCAHTOA. So I'll use sine of theta equals opposite over hypotenuse, or you could have just wrote this. I honestly took that as an equation. This was an H though. So let's see. Theta equals the inverse sine of my opposite, which is 61.3 newtons, divided by my hypotenuse, which is 127 newtons. So inverse sine, second sine, 61.3 divided by 127. Enter. Make sure you're in degree mode still. It should be just about 29 degrees. We'll round it. Why not? So that is question 2. Looking at question 3 now, moving right along. 2 wagons are tied together with some nice, love this rope, some nice rope. So here we go. 2 wagons, 1 wagon tied together. Boom, nice rope, not going to break. The cart on the left has a mass of 450 kilograms, big boy. Cart on the right has a mass of 300 kilograms. The cart on the left is pulled towards the left with a force of 900 newtons. So this was a wild card. Really mixed it up on you and put the arrow on the other side. So force equals 900 newtons. All right, and they want us to draw a free body diagram. Did it. Calculate the acceleration of the system. All right, so the acceleration of the whole system. I want to think of everything. So this is not 2 separate things, it's one big thing. So I'm just using Fnet equals ma. Fnet is 900 newtons because that's the only force pulling the system. There's a force, but that's internal. Equals my mass, which is 450 kilograms plus 300 kilograms times A, solving for A. So A is 900 divided by what? 750. So 1.2 meters per second squared. And then the next part of this question says, well, find the tension force. This is 3C. So to do that, you only want to look at one of the blocks. They both have a tension force, Ft. This one has tension pulling this way, Ft. I'm going to look at this block here on the right, though. Let me zoom in. So I'm going to look at the block on the right because there's only one force acting on it. So I'm going to do Fnet equals ma again. But Fnet in this case is just tension force. If we did this block, Fnet over here is F plus Ft. So you just have to substitute in 900 over there. But I like this because I don't have to do that. So my mass of just that block is 300 kilograms. A lot of students left it as 750. Acceleration is 1.2 meters per second squared. We just found it. So force of tension is equal to 300 times 1.2. That's equal to 360 newtons. Some people used 450 because in the homework and practice problems, we used 450. But that block has two forces acting on it. We're picking the block that only has one force acting on it. And now the last one. Here you go. This is a cart. It's free to move. M1, mass 1. M2 is over here. Free to move around pulley. No friction. Blah, blah, blah. So which cart, part A, which causes the system to move in Y for 2 points? So M2. And that's because there's no table or no normal force to stop gravity from pulling it down. So gravity can pull it down. It's going to move. There you go. Part B. What would happen to the acceleration of the system if mass 1 was increased? So this, instead of being small, is much bigger, much heavier. But M2 stays the same. So what's going to happen here is this is an Fnet equals ma question. So in this example, you've got Fnet equals ma. So the net force is coming from M2. M2 is what's creating the force. So the force stays the same. The overall mass of the system is going to increase in this one, which means to balance that increase out, we're going to have to decrease our acceleration. Also, think about it. You have the same force pulling a heavier mass. You've increased the inertia of M1. It's going to be harder to move, so you're going to get less acceleration. Question C is the flip of that scenario. So now you increase the mass of M2, you're going to get more force. So you're still getting more mass in the system, but you're also getting more force. And the overall force, if you were to double this, you double the force, you wouldn't double the overall mass because it's two parts. So your force is increasing more at a faster rate than your mass is. So you're going to get more acceleration in part C. So what would happen if you increased M2 but left M1 the same? So you get more force pulling the same object, more force, same object. You're going to get more acceleration on it. All right, so that is all of the possible 4 questions you got for the part 2. You only got 3 of them, and you didn't even get all parts of each question of the 3 that you saw, but that covers all the bases. Now you know how to do every question on the exam. So let me know if you have any questions. And again, we're still undecided. Please tell me what you want to do as a makeup to earn points back on this test. I'm all ears. See ya.